In this lesson, we shall solve question 8 and other questions to follow. In the diagram below, tangent KT to the circle at K is parallel to chord NM. Chord NM. NT cuts the circle at L. NT cuts the circle at L. Triangle KML. KML is drawn. Angle M2 is 40 degrees. Right, we have the angle M2, it is 40 degrees over here. Okay, moreover, we have that the angle MKT is 84 degrees. MKT is 84 degrees. Determine giving regions the size of the angle K2. And where is the angle K2? It's this angle here. And the question we're asking is, what is the size of this angle K2 here when KT is a tangent to the circle? Right, quickly, who can give that one an attempt? Who can put in an effort to find the angle K2? Right, a quick suggestion from you and then I give the answer. Angle K2 equals what? Right, anyone home? Angle K2 equals what? Right, here's the angle K2, and it's very, very straightforward. What we can see is, we remember our grade 11 geometry, that if there's a circle and a tangent to the circle, that is a line, straight line that touches the circle at most at one point only, and that is called the tangent to the circle. And we have, therefore, the angle that sits between the tangent to the circle and the chord equals the angle in the alternate segment. So the angle here equals the angle there. And this here is nothing other than the tan chord theorem. We have the same thing here. We have a tangent here because KT, tangent KT. We have the chord here like this, and you have this here, and we have this here. So the angle between a tangent to a circle and the chord equals the one in the alternate segment, in which case, therefore, we have K2 is equal to angle M2, which is 40 degrees. Angle K2 equals angle M2 equals 40 degrees. Why is this the case? Why is angle K2 equals angle M2? Okay, the reason is that it is because of the tan chord theorem. Tan chord theorem. So what do we write as the reason? We write tan chord theorem. And this is how we write it in the exam. Okay, these things are then grade 11 and that metric as well. So you need to make sure that you pay full attention, because they're going to trouble you for some good number of months, or full 2 years, grade 11 and matric. So they are these things exactly. The next thing is we want to know. So we found the angle K2, and the angle K2 is actually equal to exactly 40 degrees, and you can come here in the diagram and be able to put it here, and you say, okay, Mr. Examiner, this angle K2 has now been found, and it is actually equal to 40 degrees, like so. Next, we are interested in finding the size of the angle N1. This one, what is the size of the angle N1? There it is. The question remains, what is the size? Next question. Next point, angle N1, this one here. What is the size of this angle here? So this angle here is equal to what? Who really can give us an idea? Who thinks they can be in a position to determine the size of the angle N1? Who knows? But now to find angle N1, we go back to grade 11. Grade 11 teaches about the bow tie angles. Right, it's a bow tie, and this angle here equals this angle there. This angle here equals this angle there. And we say that these are angles in same segment. Angles in same segment. Okay. So what is the size of the angle N1? This one. So clearly this is a bow tie. This angle here is actually equal to the angle there. But also, I mean, you can say this angle is subtended by this arc here. So this arc here subtends this angle, but this same arc subtends the angle K1. The arc ML subtends angle N1. The arc ML subtends angle K1. And therefore, we have the size and angle N1. Right, so the angle N1 is equal to what? Right, so we're able to see clearly what that is. The angle N1 equals the angle K1. These are angles in the same segment. Angles in same segment. Angles in the same segment. So this one here is equal to this one there. Next point. We're interested right now in finding the size of the angle K1. But now there are a couple of things that we know, because we know that this one is 40 degrees. We just got it. K2, we know it's 40 degrees. From where? From the previous question. We got K2 to be 40 degrees already. We just need to find the size of the angle N1. Okay, good. What is then the size of the angle K1? Now we're interested in finding the size of the angle K1. What is the size of the angle K1? This one here. The size of the angle K1 equals what? Right, so we know the whole angle is 84. It is 84, so which means therefore the angle K1, which is here, is the whole angle, the overall angle. The overall angle 84 minus the little bit, minus the 40 degrees, and we have 84 degrees minus the bit, 40 degrees, and 84 minus 40 degrees will yield a 44-degree angle. Okay, so if you take the whole angle and you minus 40, you get actually the little bit K1 here, which is 84 minus 40, and that is 44 degrees. And obviously, I mean, that is very, very clear there. Okay, this is true because of angle addition. Now, that's a trivial reason to state, but we proceed, therefore, to solve more problems. Now, we want to find the angle N1. What is the size of the angle N1? Right, so we then say, thus, the angle N1 is actually equal to, right, remember we said the angle N1 was K1. We got K1 to be 44, which means the angle N1 equals 44 degrees. Okay, once again, I give you homework. So because of these things here, so this one is 44 degrees. I give you homework, so y'all be ready to do more, but more and more. We found, therefore, that angle N1 is 44 degrees. Angle N1 is 44 degrees. If you have a question, please ask. Do not be afraid to ask, because we are training you to reason. This is geometry. I sent you homework. You need to do that homework. You have the whole week to do that homework, because it's just a bit more questions on overall geometry. If you can do those questions, then you know everything in geometry. But you must watch the videos first before you do those questions. Watch the videos first before you do the questions. Next question. The next thing is we need angle T. Angle T. This one. What is the size of the angle T? Who can tell us the size of the angle T? Anyone home? What is the size of the angle?
Say the
Yes. What do you think?
the size of angle T is 44 degrees.
It is 44 degrees. Wow, this is marvelous. Angle T, because you can see this one here. It's doing this.
Yes.
And it's doing this.
Out.
Yes. Now, these, what do you call these angles that are like in this kind of shape here that do this? What do you call these angles here? We call them alternates. Right. So, yeah, you're so right there. That is Nombuso, right? So, right, angle T. Angle T is equal to the angle N1. Angle T equals the angle N1. This N1 is already 44 degrees, which means that angle T itself equals N1, which is 44 degrees. Why is this the case? These are alternate angles. Alternate angles. Why are the alternate angles? KT is parallel to NM. Is parallel to NM like this. KT is parallel to NM. So in other words, we have got the angles here. We have got that the angle K2 is 40 degrees. 40 degrees. We've got that the angle N1 equals 44 degrees. And we've got that the angle T is actually equal to 44 degrees as well. Next story. We want the size of the angle L2. L2. Where is L2? This is L, and we want this one. What is the size of that angle there? We have the angle L2, but we want its size. This one, what is the size of this? What is the size of this angle, people? Anyone home? Anybody home? What is the size of the angle L2? Who knows? Because we know that this
84,
one...
sir.
Okay, well done. It is exactly 84. Okay, good. Thank you so much, Tenulo. That is Tenulo. Right, so you have that this one is this K2. We know very well that K2 is 40 degrees. So we've just got that one. We know that this one is actually 44 degrees, and the T is 44 degrees as well. So N1 is 44 degrees. The angle T is 44 degrees. So yeah, we want to find the size of the angle L2. Okay. Angle L2 is this guy here. And this one takes us back to grade 10. At grade 10, they taught us that if there's a triangle like this, right, let me just draw a nicer triangle a little bit. Right, at grade 10, okay, I know very well that no one is doing grade 10 here because I accommodate the grades that are here. Okay, so now this is CAB. 1, 2. Angle C1 is A plus B. Okay, angle C1 is A plus B. Angle C1 is, so now we say exterior angle of triangle. So exterior angle of triangle. So now C1 is A plus B. Okay, this is what we're taught in grade 10, that we can find the size of this angle C1 and see, we just say C1 is A plus B. So it's the same thing here because we have this here and we have this here and you have that. So it means therefore this angle L2, angle L2 is equal to angle K2 plus angle T. Why is this from grade 10? This angle is sitting outside this triangle here, which means that it's exterior angle of triangle. Good. Right, so we are in business and some of these things have been seen before. What is the angle K2? It's 40 degrees. What is the angle T? Okay, it's 44 degrees. And therefore, the angle L2 is 40 plus 44 gives us actually 84 degrees. So that the angle L2 is actually 84 degrees in size. Awesome stuff. So we got L2 to be 84 degrees. Now we need angle L1. Angle L1, let's see. L1. L1. Right, so the angle L1 is this one here. What is the size? Who can tell us the size of the angle L1? Anyone home? Who knows that one? Maybe I'm going to give Senulo and Tando a break because I know very well that they had a fair chance in the afternoon to go through a bit more geometry questions. But I know very well that some of the guys have been off. So I know very well that Pechalelo and Nombuso have been off. They've been off the radar in the afternoon. So yeah, I'm interested in knowing what is the size of the angle L1. Who knows the size of the angle L1? Who can tell us? I'm giving Tenulo and Tando a break for this question. For this question. The other questions where I'm gonna like involve you guys. But for this one, Nombuso and Pekelelo, this one is 40 degrees. T is 44 degrees. So it helps to just put in the angles that you know. Okay, this one you know very well is 84 degrees. Right. Right, so you continue. We continue. All right. So yeah, we need angle L1. So we continue. Right. So we need L1. I need some people to tell us what the angle is. Okay, we continue. Right. Who knows, but I mean, I have people here. I have Pekalelo, I have Nombuso. Guys, what is the answer? What is L1? We need L1. What is it? I lost Pekalelo. I'm so sorry. I lost her. If I lose you, please try to rejoin because now I think that it can just be the network. Can just be the network that is making it tricky. If I lose you, please rejoin. If I lose you, join again. I'm asking the question, what is the size of the angle L1? That is the question we're asking. L1. What is the size here of the angle L1? What is it? Who knows L1? Who can find the size of the angle L1? No one knows.
So can I try?
Yes, please try. Try.
I think it's 40 degrees.
You think it's 40 degrees. That's okay to try. That's okay to try. That is a number, so okay. Right? Am I right? Okay, that's fine. Right, so we're doing L 8.1.5 L1. So to do that one, we're going to work in triangle KML or triangle KLM. So yeah, we're going to test your answer there. So in triangle KLM, we're just showing the steps. Then we're going to do what? Okay, this one is 44 degrees. So we're going to take, because it's 44 plus 40, which is 84. So we're going to take in that triangle there, we're going to take 44 degrees. We're going to take 44 degrees. Then we're going to take this angle here. So we take 44 degrees. Then we take 84 degrees. 44 degrees plus 84 degrees plus L1 plus 40 degrees. 44 degrees plus 84 degrees plus L1 plus 40 degrees. If you add all of them, you get 180 degrees. This is the sum of the interior angles of a triangle. Right, and the reason for this is angles sum. Angles sum in triangle. Right, so that in the end, then you have the angle L1, which is 180 degrees minus. So we have the 44 plus 40 is 84. 84 plus 84 is 168 degrees. So that angle L1 is, what is 180 minus 168 degrees? (180 minus 168 degrees? So now we're getting 12 degrees. So that the angle L1 is actually equal to 12 degrees. It can come here and put exactly 12 degrees there. Okay, so the angle L1 is actually equal to 12 degrees. How did you get the angle L1? We added this one, we know is 44. How do we know this one is 44? Because it is the whole angle is 84. We got K2 to be 40 degrees. We got N1 to be 44 degrees. We got angle T to be 44 degrees. We got L2 to be 84 degrees. Now, this one is 44, this one is 84. We wanted L1. This one, M2, is 40 degrees. It was just given like that. Okay, so we added 44 plus 84 plus L1 plus 40. And the sum is 180. Why? Because it's angles sum in triangle. Right, and then we just solve for L1, we're getting 12 degrees, which means the angle L1 is 12 degrees. Where's the question? Or where's the contribution to make? Maybe you are seeing a mistake somewhere. Maybe you can see that, okay, there we've put 2, but there should be a 5, you know? So you alert us to say, hey, please check this, check that. And we are happy to do so. This lesson is recorded, and once again, you'll have an opportunity to watch this again. You'll have a chance to watch this again. Next question. Right, the next question is this one here. The next question is this one. In the diagram below, this one here, A, B, and DC are chords. A, B, D, C are chords of a circle. E is a point on AB. Here is E, and E is a point on AB such that BCDE is a parallelogram. DEB is 180 degrees. DEB is 180 degrees. And DAE is 2x plus 40. DAE is 2x plus 40 degrees. Like so. Calculate giving reasons the value of x. The value of x. What is the value of x? What is the value of x? What is the value of x? Right, so obviously because the examiner told us that B, C, D, E is a parallelogram, grade 10 work. B, C, D is a parallelogram, grade 10. Parallelogram means the opposite sides are parallel to each other, but they also equal. This side of the parallelogram must be parallel to the opposite side like this, and they are equal to each other like this. Right, so that angle C is 108 degrees. Right. If you have a question, Nombuso, no question. Okay. Right, so that in the end, then we're interested in finding the value of x. What is the value of x? What is the value of x? Angle C is also 108 degrees because at grade 10 we're taught that the opposite angles of a parallelogram are equal to each other. So in other words, this angle is 108 degrees, but also this one is 100 and what? Is 108 degrees. So we have that these are actually the opposite angles of a parallelogram are equal to each other. Okay, next. We learned at grade 11 that if you have a cyclic quad, then the opposite angles of a cyclic quad are supplementary. Okay, if this here is A, B, C, D, it therefore means that angle A plus angle C is 180 degrees. So that in the end, what we then have is these are opposite angles here. So we then say that these are opposite angles of cyclic quad. Okay, we know that opposite angles of a cyclic quad do what? Are supplementary angles. Okay, this is awesome news, and we are in progress. Now, we really are making significant progress so that now we are able to say we can add this one plus this one. So in other words, we have that angle A plus angle C, because they're opposite like this. Okay, so A plus C is actually equal to 180 degrees. Why is angle A plus angle C? In the same way, you could say D plus B, angle D plus angle B. But again, the issue with that is we don't know this. Yeah, want X, so X is part of the angle A. So therefore, we say angle A plus angle C is 180 degrees. Why? Why is this the case? Why is angle A plus angle C equal to 180 degrees? These are opposite angles of cyclic quad. These actually are opposite angles of cyclic quad. These are opposite angles of cyclic quad. So right now the angle A is what? The angle A is 2x plus 40 degrees plus the angle C. Hey, please, examiners. Okay. Here we meant 108 degrees. This is equal to this 108 degrees, please. 108 degrees, not 180. But obviously, if you add the opposite angles, A plus C, you're getting 180 degrees. So that the angle C is 108 degrees, which is 180 degrees. And this is 2x equals 180 degrees minus 148 degrees. 2x equals, what is 180 degrees minus 148 degrees? 180 degrees minus 148 degrees, we get exactly 32 degrees. And therefore, we have 2x, we divide by 2, you have 32 degrees, we divide by 2, and what is the result? The result is that x is equal to 16 degrees. X equals 16 degrees, and this is the answer to the question. Who has a question? Who has a contribution to make? Who has an observation that, hey, this angle here should be that. This angle here should be this and that. So you are let us, if you have a question, to say, hang on, this and that should be 5, should be 1 billion, should be 1 million, should be anything else. Please alert us, and we are aware of that, and we rectify accordingly. We are learning, and we are moving forward. Where's the question? Right, it appears that there's no question. In the absence of a question, we move forward. We move forward. We move to this question. This question is grade 10 work, actually. But obviously now it's here at grade 11 metric. And it's keeping the grade 11s on their toes. And it's making them to think more of geometry. Let's get the grade 11s to think. I've sent you the homework, please. That homework on the group, you need to try it. I'm going to send you the answers to those questions. But yeah, it's very important that you try first, because I don't want to just send answers to things that I'm going to send you thousands of questions on the group. The questions are coming. So many, but I must send them bit by bit. I can't just send so many questions there, because otherwise then you're going to be dissuaded. And I don't want you guys to be dissuaded. In the diagram below, EO. In the diagram below, here's the diagram. You have EO, right? EO bisects AC. EO bisects AC of triangle ACE. Okay, yeah. EO bisects AC of triangle ACE. EDO is produced to be. EDO is produced to be. Okay, here it's EDO is produced to be such that BO is equal to OD. Right, such that BO is equal to OD. Okay, BO equals OD. They marked them equal here. AD and CD. Right, we have that AD and here's AD and CD produced meet EC. They meet EC and EA at G and F respectively. You can see the G, you can see the F. Give a reason why A, B, C, D. A, B, C, D. Give a reason why A, B, C, D is a parallelogram. Grade 10 work. Grade 10 work, and none of you is doing grade 10. Everybody passed the grade 10 here. Give a reason why ABCD is a parallelogram. Why is this? What property of a parallelogram does this diagram here satisfy? What property? Because ABCD is a parallelogram. Why is it a parallelogram, this ABCD? It is a parallelogram because the diagonals of quad bisect each other. Because the diagonals, we write diarcs of quad bisect each other. Diarcs of quad bisect each other. So that ABCD is a what? ABCD is a parallelogram. Why? Because here's a diagonal, here's another diagonal. This diagonal is bisected because it is divided into two equal parts. This other diagonal is also bisected, it's divided into two equal parts. So in other words, we're to give the reason why ABCD is a parallelogram. So ABCD is a parallelogram because the diagonals of quadrilateral bisect each other. Next question. This is grade 10. The parallelograms and rhombus and whatnot. Grade 10 work. Write down with reasons 2 ratios equal to ED. ED. B. Write down the reasons 2 ratios each equal to ED over DB. In other words, now you already have a parallelogram. What do you know about a parallelogram? This side, the opposite sides are parallel and equal to each other. But also now you also have that this one is parallel to that one. And then now when you get to this point, you are looking at ED, right? So you have E and D, and then you have D and B, like this. Okay, so which means that now look at this. This is where the E, the D and the B lie. Okay, they lie on this line, but now, yeah, I'm just sort of tracing the line here. So you have the E, the D, and the B. So also it is such that now this is parallel to this, but this is extended to that. So you have this. And then now we take you to the proportionality theorem. And that is it's very similar to a special case of the proportionality theorem is what we call the midpoint theorem at grade 10. Right, what is this theorem? If this one is A, B, C, D, E, which means AD over DC is equal to AE over EB. AD over DC is AE over EB. Okay, and this is the proportionality theorem. So this is the proportionality. We write the proportionality theorem like that. If you see, okay, if you see a line parallel to one side of a triangle, then it divides the other two sides in the same proportion. So that you can say AD, if you have a triangle like this, you say AD over DC is equal to AE over EB. Okay, watch this because that is the rule we want to use. The examiner wants us to use it here in 9.2. They are saying, the examiner is taking already, they're saying write down with reasons 2 ratios each equal to ED over DB. So ED over DB. Now you're going to write here ED over DB in the exam. It's equal to what? So ED over DB is equal to, okay, you can see now there's a line that is parallel. This triangle has been rotated now. It has been rotated to lie on its side. But if you have ED over DB, it must be equal to what? It must be equal to this one here. Okay, because now you're able to see that this one here, we can do this. And this one here, we can do this. So that we have EF. ED over DB is going to be EF. Now, when you say DB here, you say FA. Like this. Okay? And that is what we have. And the reason for this is nothing complicated. Why are we writing these things like this? Why? Because of the proportionality theorem. So the reason for this is that we have the proportionality theorem. Next, but we need two ratios. So now we also have this, but we also have ED over DB. Right, ED over DB is equal to what? So you have this here. Like this. So ED over DB is equal to, now, okay, you also have that this one is parallel to this, because the opposite sides of parallelogram this. But this one is extended here so that you also have this triangle here. So this triangle here, this one, has been now rotated. It's lying on its side, but the examiner is taking ED over DB. And then you must tell the examiner that then you, on this side here, you have EG over GC. And this is the proportionality theorem. Proportionality theorem. Okay. Please forgive me if I lose you. If I lose you, forgive me, because the system might just be the network. As said already, I'm gonna be using multiple systems this coming from the coming weekend. I'm gonna be using multiple systems like your thing, what we call the Microsoft Teams as well, so that you have two options. And we have an opportunity to test these systems and see which system is okay, you know. And now we need to make sure therefore that everything goes very, very well. So so stay put and stay tuned. Is there anyone with a question here? Who has a question? If you have a question, please let us know. If you have a question, let us know. If you have a question, you highlight to us that, okay, there's a question, and then we can answer that question and make sure that everything is very much okay. And make sure that everything is very much okay. Right. So once again, this is the proportionality theorem. For this 9.2 question, we have to write down the reasons, two ratios, each equal to ED over DB. So with ED over DB is equal to EF over FA. ED over DB is EG over GC. Proportionality theorem. Proportionality theorem. Proportionality theorem. Proportionality theorem. Okay, next question. The next thing is now to just prove some results. So we want to prove that 9.3. Right, want to prove 9.3. In 9.3, we want to prove that A1 equals F2. Angle A1 is equals to angle F2. We want to establish this. Angle A1 is equals to angle F2. Want to establish this. So how do we establish this here? Right, angle A1 is equals to angle F2. So how do we prove this, that angle L1 is equals to angle A1 is equals to angle F2? How do we establish this? Very, very easy to establish this result. And to establish this result, there are a couple of things that remain very, very important. We already know that this one is a parallelogram, so these opposite sides are parallel to each other, right? And also this side is parallel to this one because they're opposite. So that now we are in business, and then we continue to, so in other words, we have that the angle A1, for instance, is equal to the angle C2, because if you have the angles in Z, so A1 is equal to the angle C2, or like that, right? So it remains to just now have a way to verify that indeed this angle here, the angle C2, is equal to the angle F2. So Yeah, we're in business. Let's just establish that one part. Right, so this is how we prove this one here. So the couple of things that we need to use in 9.3, but first, because what do we know from the previous results? Previous results. Right, so okay, in 9.2, you already have ED over DB. Right, so ED over DB, we've seen that it is EG over GC. Okay. ED over DB. ED over DB is equal to EF over FA. Right, in each case, we saw that it was here for the ED over DB. It was done for this question. And this is the proportionality theorem. But also this one is the proportionality theorem. So that in this case now, we already have this. But the actual conclusion now that comes out of this, the actual result now that comes out of this, okay, if we have that, okay, let me write at the bottom here, not write things that are going to be strange to you, but I want to make sure that this is okay, because this one, it's ED over DB, ED over DB. So as a consequence, what we're having is therefore that EG over GC, EG over GC is EF over FA. Because it's ED over DB, it's ED over DB, so ED over DB, it means that these things are also equal to each other, because this one is equal to ED over DB. But something different is also equal to ED over DB, which means that EG over GC is equal to EF over FA. So it's a therefore conclusion here. Okay. Now, what is this? What is this? As a consequence, then, we have the following. We have the following. We have the following, guys. We continue. We continue. What do we continue to do? Okay, this conclusion that EG, let's check it again. We have EG over GC. This conclusion is equal to EF over FA. What is the meaning of this? It means, therefore, that this line here and this line here are parallel lines. Wow, kudos. Okay, learn the geometry because you are expected to know how to apply it, how to prove things like this. So, and that means, therefore, it means, therefore, that AC is parallel to FG. AC is parallel to FG. So, yeah, the reason for that is line divides two sides of triangle in proportion. Line divides two sides of triangle. Line divides two sides of triangle in proportion. Line divides two sides of triangle in proportion. Okay, AC is parallel to FG. Right, okay, if we lose you, please forgive me because it's the network, it's whatever the reason. From next weekend, I'm going to be using 2 platforms, and I'm going to be sending 2 links so that you can have a choice. There might be stronger, maybe Microsoft Teams might be better. Okay, whatever. If one gives you a problem, then you can switch to the other. Right, so we have that AC is parallel to FG, but this is recorded. Even if you are locked out, but the recording is having everything from the beginning to the end. We are recording our discussion. Okay, this is higher mathematics. It's not for kids, this is higher mathematics. So that AC is parallel to FG. Okay, now look at this. But look at this carefully. If AC is parallel to FG, aha! The angle C2 is equal to the angle F2. So we have a conclusion. Therefore, the angle C2 is equal to the angle F2. The angle C2 is equal to the angle F2. Alternate angles. AC is parallel to FG. AC is parallel to FG. Okay, note that if AC, because if AC is parallel to FG, it means that we can see angles in Z. So this C2 is equal to F2 because this makes a Z. Okay. Right. Now, what else do we say? The angle A1 is equal to the angle C2. We state here. The angle A1 is equal to the angle C2. The angle A1 is equal to the angle C2. So the angle A1 is equal to the angle C2. These are alternate angles. Alternate angles. AB is parallel to CD. AB is parallel to CD. Therefore, okay, if A1 equals C2, okay, but C2 is F2, well, the conclusion, therefore, is that the angle A1 is equal to the angle F2 because F2 is C2, C2 is A1. It means A1 is F2. Okay, so we have been able to achieve this. Right, we have been able to prove, therefore, that angle A1 is equal to the angle F2. Where's the question here? Where's the question? Where to prove, therefore, here that angle A1 is F2. Sometimes these things are not going to make sense to you same time. It's a lot of steps here, and you're trying to make sense of this. It's normal, but don't give up. Don't give up. Keep going. Believe. Believe. Believe you will master the geometry. Geometry is about repetition. You repeat, you repeat, you repeat, you repeat. You watch the video, and then after watching the video, you don't just watch the video from the beginning to the end because you're going to forget. You watch one question and then you try that one question. Then you watch another question, then you try that question, and so on until you finish everything. And then continue like that. You watch a little bit and then try that little bit until these things sink in your head, because they want to ask you these things in the exam. We have done 9.3 that says proves that angle A1 equals angle F2. Angle A1 equals angle F2. The next thing is to do 9.4. The next thing is to do angle 9.4. Now, if it is further given that A, B, C, D is a rhombus, if it is right, it is given that A, B, C, D is a rhombus. What is a rhombus? Rhombus means that all the sides are equal and parallel. The opposite sides are parallel, but the diagonals bisect each other at right angles. So these diagonals make angles of 90 degrees with each other. Okay, so yeah, that is something that you need to take care of and that you need to take note of. Now, okay, so we need to prove that AC, GF. ACGF. ACGF is what? It's a cyclic quadrilateral. ACGF is a cyclic quadrilateral. Let us prove this. So to prove that ACGF, here is A, here is C, here is G, and here is F, is a cyclic quadrilateral. Right, to prove that it's cyclic quad, we can prove that there's a bow tie here. We can see the bow tie, but we must prove that the angles are sort of equal to each other. Like we can prove that this angle A2 is equal to this angle F2. So now we can start by saying the angle A, so we're doing 9.4, but in doing 9.4, we're able to see that the angle A1 is equal to the angle A2. This takes you back to grade 10. Remember the properties of this. So grade 10 teaches us that if you have a rhombus, then the diagonals of a rhombus bisect the angles. So that angle A1 is equal to the angle A2, and these are diagonals of rhombus. Diagonals of rhombus. Diagonals of rhombus. So angle A1 is equal to angle A2, and these are diagonals of rhombus. Right, so if these are diagonals of a rhombus, then what they do is they bisect angles. Okay, right. Now, moreover, we have that from the previous result here, remember, want to prove that this angle A2 is equal to F2, but we know that angle A1 from the previous question, we know that angle A1 is equal to the angle F2. Why? Why is angle A1 equals to angle F2? Angle A1 is equals to angle F2 because we proved it here. So this one has been proved. It has been proved in 9.3 above. We have proved the fact that angle A1 is equal to angle F2. Angle A1 is equal to angle F2. Here, A1 equals F2. I mean, that was proven above. So what then is the next thing? If A1 is A2, angle A1 is F2, right? What is then the conclusion? The conclusion, therefore, is that angle A2 is equal to the angle F2, because this is A1 is A2, A1 is F2, and that then means, therefore, that the angle A2 is equal to F2, because these guys are both equal to A1. This one is A1, this one is A1, so which means that A2 is equal to F2. Okay, when I send you the homework, you watch the videos, and then you do the homework. Okay, we have that angle A2 is equal to angle F2. Hey, this is mathematics, my friend. It's not joke. Therefore, ACGF. Therefore, ACGF. So you can even write the conclusion here. Let's write it here. Therefore, ACGF. Okay, just write a G here. Therefore, ACGF is a cyclic quad. It's a cyclic quad. Right, and these are angles in the same segment equal. Angles in the same segment equal. Right, so we are saying that the ACGF is a cyclic quad. Why is it a cyclic quad? ACGF is a cyclic quad. Angles in the same segment equal. Because there's a bow tie. bow tie, although there's no circle, normally there has to be a circle, but there's a bow tie like this, so that you can see that we just had to show that angle A2 is equal to F2, and we have done that. So we can see therefore that angle A2 is equal to the angle F2. And this has allowed us to conclude that ACGF is a slightly quadrilateral. ACGF is a slightly quadrilateral because the angles in the same segment are equal to each other. Okay, once again, if I lose you, forgive me there. Okay, next question. Right, this is one question that's very important in the diagram below. Triangle ABC. Triangle ABC and triangle PQR are given with angle A equals P, angle B equals Q, and angle C equals angle R. DE is drawn such that AD equals PQ and AE is equal to PR. Prove that. So we want to prove, therefore, that here, prove that triangle ADE is congruent to triangle PQR. Triangle ADE is congruent to triangle PQR. Okay, this one is grade 10. Right, so to prove this one, the lines, those three lines that are lying down, what do they mean? They mean congruent. Congruent, there are 4 cases of congruency done at grade 10, and we sort of remember those right now, and we make the most of that. So we then say that in triangle ADE and triangle PQR. Okay, so we want to prove that this triangle ADE is congruent to the other triangle ADE. Okay. AD. Okay, in this triangle ADE and the triangle PQR, want to show that these two triangles are congruent. Right, let's see what you can get. But we know that AD is equal to PQ. Okay, we must just identify some equal sides and angles. Right, this is equal to, angle AD is equal to PQY. Construction. Next, what is AE equals PR? AE equals PR, why? Because, okay, let's first write this one. Let's put them in some order. So now, to put them in some order, you can see that this angle A is equal to angle P. Angle A equals angle P. So with angle A equals angle P, why is angle A equals angle P given? And then now you have that angle AE is equals to angle AE is equals to angle PR. Angle AE is equals to angle PR. Construction. Angle AE equals angle PR. Construction. Therefore, triangle ADE is congruent to triangle PQR. And this is side angle side. Okay, side angle side, because we have that we want to prove a grade 10 concept on the congruency of two triangles, triangle ADE and triangle PQR. So we know that AD is equal to PQ, angle A is equal to angle P. It's given here. Angle A is equal to angle P, but AE is PR. So that triangle ADE is congruent to triangle PQR. Okay, so yeah, which is exactly side angle side. And then we have proven this one. We have to prove that these two triangles are congruent, and we have proven that these two triangles are congruent. The reason is side, angle, side. Next, we need to prove 10.2. In 10.2, we need to prove that DE is parallel to BC. DE is parallel to BC. Right, we need to prove that DE is parallel to BC. To prove that DE is parallel to BC, let's continue. Oh, this one. Let's prove this one. Okay, now first to prove this one, 10.2, 10.1.2, we want to prove that this is parallel to this. So we need to identify some angles here that are going to form something like this. If this angle is equal to this, because at grade 10, we're taught that this angle, if this angle is equal to this, if this line is parallel to this, then these angles are equal, and these angles were called corresponding angles at grade 10. They're called corresponding angles. So we're going to use these. Right, and now to use this, we proceed as follows. So now I want to prove 10.1.2. Angle ADE is equals to angle Q. Angle ADE is equals to angle Q. This angle here is equal to this angle there. Which means that triangles that are congruent, well, because we know that this triangle ADE is congruent to triangle PQR. So if triangle ADE is congruent to triangle PQR, right, we can therefore say the corresponding angles are equal. So in other words, we then say therefore corresponding angles equal. Right, so that ADE is equal to angle Q, but angle B is equals to angle Q. Angle B is equals to angle Q. Angle B equals angle Q as given up here. Angle B equals angle Q. And therefore, the conclusion, therefore, is that ADE is Q, B is also Q. So two angles are Q. ADE is angle Q, but angle B is angle Q. Therefore, angle ADE is equals to angle B. And therefore, DE is parallel to BC. And therefore, DE is parallel to BC. Why? Why is this the case? Because we've been able to establish here that the angle ADE, which is this one, is equals to the angle B. ADE is equals to the angle B. So yeah, these are the angles that are equal to each other. And therefore, we have that this line is parallel to this, because these angles that do this, they're called corresponding angles, these angles in F. So these are the corresponding angles. Corresponding angles equal. Corresponding angles equal to each other. Right, so yeah. That's what we have. So DE is parallel to BC. We have proven that. We proceed right now to do the last part. Okay, this one is a theorem, this is a theorem that we're proving. So please, folks, I beg you, with the mercies of God, to take note of this question 10. It was properly set for the exam, and it was set part by part, but this is just the proportionality theorem. Sometimes it's difficult to prove for the students because it's proven in two parts. So if you have triangles like this, what do you prove first? Because in the exam, sometimes they're just going to say, prove this. They're just going to say, prove this. Okay, now if they say prove 10.3, the students will be like, how? Where do I start? To start, you need to prove that this triangle here is congruent to this triangle here. You go back to grade 10 to prove congruency with the 3 lines that are lying down parallel, like parallel, but yeah, just laying down. Then you deduce that DE is parallel to BC. Deduce that DE is parallel to BC. Then, if they're parallel, then you're able to achieve, therefore, that AD is AD over, right, AD over PQ is equal to AC over PR, AC over PR. Next point. Next point. We're going to 10.3 right now. We're going to 10.3 right now. So in 10.3 now, we want to prove that AB over PQ, AB over PQ is equal to AC over PR. Hey, I'm cracking your skulls. I'm getting your minds bigger. This is the highest level of geometry you'll ever meet. So, y'all, pay attention to this because this is your future. So now, at this point, you already know that this one is parallel to this. Because of that, then you'll tell the examiner, that means the examiner, AB over AD is equal to AC over AE. Proportionality theorem. But AD is equal to what? Here are the things. AD is equal to PQ and AE is equal to PR. Construction. Construction. So that now you have AB. So that you have AB. Now the AD here, AD is PQ. So in the place of AD, you put PQ. Then you have AC. In the place of AE, you put PR. So we've been able to prove this one. We've been able to prove this one. That AB over PQ is equal to AC over PR. Next question. Right, the next question is this one. Very, very interesting. In the diagram below, VR is a diameter. VR is a diameter. Right, in the diagram below, VR is the diameter. So if this is a diameter, it subtends an angle of 90 degrees there. Of a circle with center O. S is any point on the circumference. S is any point on the circumference. P is the midpoint of RS. P is the midpoint of RS. So it is in the middle. Obviously, the examiner marked it for us. If P is the midpoint, so it is in the middle, so that this bit equals this little bit over there. Next. We also have that the circle with RS as a diameter. There's a circle with RS as a diameter. Okay. So if you have this RS as a diameter, it means it subtends an angle of 90 degrees. Right. Right. Cuts VR at T. VR is cut at T. ST and OP and SV are drawn. ST and OP and SV, right, and SV are drawn. Why is OP perpendicular to PS? Here is O, here is P, and then here is S. Why is OP perpendicular to PS? Grade 11s, answer the question. Why is this the case? Grade 11s, answer the question. Why is OP perpendicular to PS? Why? Why is OP perpendicular to PS?
Oh, sir, can I try?
Yes, please try. That's Mambuso, yeah?
Okay. It's a line from a center perpendicular to the chord.
Yes, yeah. Okay, thanks for the for trying the numbers. Right, it is obviously that result there. And this result is due to the fact that at grade 11, we are taught that there's a theorem that says that if you have a situation like this, and there's a line from the center to the midpoint of the chord, if we have a situation like this means that it is perpendicular to this chord. So line from the center to the midpoint of the chord is perpendicular to the chord like this. Right, so that in the end, then this is what you have. So if you have a line from the center, and here's this line from the center to the midpoint of the chord is perpendicular to the chord. So now, why is this? Their reason to be written, you need to say line from center. You need to say line from center to midpoint. To midpoint of chord. Line from center to midpoint of chord. Right, so that line from center to midpoint of chord is indeed perpendicular to the chord. Because, and the reverse is true. If you have a line that is perpendicular to a chord, line from center perpendicular to a chord, bisects the chord. Bisects the chord. And obviously to bisect the chord is to divide the chord into two equal line segments. Okay, right. Next thing, what then are we doing here? What then are we doing here? So we need to now establish something that is very important. So we need to prove that triangle ROP is similar to triangle RVS. Let us prove this one. Triangle ROP is similar to triangle RVS. ROP is similar. Similarity means that it means equiangularity. Means I just prove that the angles of this triangle are equal to the angles of this triangle. That's all. It's nothing strange here. So, but now let's take note of those of the triangles. ROP, RVS. Those are the two triangles. You just need to establish the fact that this triangle ROP and triangle RVS are equiangular triangles. So let's prove that part. So to prove, therefore, that triangle ROP and RVS are equiangular triangles, we proceed as follows. Right, first things first. Now, what do we know here? For example, right, so we are in business. We are certainly in business. So we're going to say in triangle ROP, in triangle RVS. Okay. ROP, triangle ROP and triangle RVS. ROP and triangle RVS what do we have in triangle ROP and triangle RVS? First things first, the angle R is equals to angle R, which is common. Okay. And then now we have angle O2, which is common. Okay, but now also it is very important to note that this OP is actually parallel to VS. OP is parallel to VS because of the midpoint theorem. This is a radius, and this is also a radius because O is the center. O is the center. So if O is the center of the circle, because that's what was said here, right? Circle with center O. O is the center, so that you have a radius, and these are equal, but these are equal as well. So that you're able to say OP is parallel to VS. Why is OP parallel to VS? Midpoint theorem. Midpoint theorem. Midpoint theorem. So that with OP parallel to VS, OP parallel to VS, which is the midpoint theorem. So that now what we're then having here is that because this is parallel to this, so the angle O2 is equal to the angle V. Right, the angle O2 is equal to the angle V. Why is angle O2 equals to angle V? Corresponding angles. Why the corresponding angles? Because OP is parallel to VS. OP is parallel to VS. Okay, because if this OP is parallel to VS, then you have these angles, they're called corresponding angles. Grade 10. If this is parallel to this, then this angle equals this, which are corresponding angles. Why are we even saying these things? Why are we saying these things? Okay, let's see what we've done now. We have established angle R equals angle R, but angle O2 equals angle V, which are equal angles. And then now we have that also. Now we're dealing with angle R, triangle ROP. Yes, please.
Why is OT not angles at center is equal to 2 times angle at the circumference?
Okay, that's a good point. Why is it not angle at center is 2 times angle at circumference? Yeah, the reason is that angle, I get your point. So your angle at center, angle at circumference looks like this. Yeah, it looks like this. So now we must identify if this looks like this. Right, so obviously, I mean, there's an angle at center here, but this is not, it would be that angle at center is twice angle at circumference, but this angle here this one is an angle at center, and now it would have, the shape would have to be something like this, you know, but the shape is not something like that. You know, the shape would have to be something like this. Then it would be that angle at center is twice angle at circumference, but obviously it's not like that. So which means that angle at the, which means therefore that what can only see, because they're just parallel lines here and it does not take this formation, which means that O2 is just equal to this angle there. Because yeah, there's also another way to see the angle at center is twice angle at circumference. So you have this here, so that this angle here is equal to this angle there. Angle at center is twice angle at circumference. This is how this appears. But obviously at this pointer, yeah, it does not take these forms. So which means that O2, because this one is parallel to this one, we can say these are the grade 10 theorems on what you call the corresponding angles up there. So we use the grade 10. Okay, but now we are back to then say, because parallel lines are in grade 10. Parallel lines are in grade 10, and then obviously that's where we learn the corresponding, the alternate, the vertically opposite angles, and so on. Okay, right, and the co-interior angles, all those are in grade 10. Right, and then now we have that we need three angles to prove that two triangles like this are similar. We need three angles. So we have that, therefore the angle O2 is equal to the angle V. Angle O2 is equal to angle V. So that now we have the angle P2. Angle P2, okay, we want to prove that this angle of 90 degrees, because this angle P2 is the one that we said is 90 degrees, because why is this? That's why the examiner asked this question, why is OP perpendicular to PS? Why is it perpendicular? Why? And we said that it's a line from center to the midpoint, because this is equal to this, midpoint. But also the examiner said P is the midpoint of RS. Right, so if it is the midpoint, then it is perpendicular there. Okay, but now the angle P2 then is equal to the angle, the whole of this angle is 90, this is 90 degrees. But why is this 90 degrees? This is 90 degrees because of what? This is 90 degrees because of the fact that this is the diameter, this O is the center. If O is the center, then from grade 11, we learned that a diameter subtends an angle of 90 degrees in circumference. A diameter subtends an angle of 90 degrees in circumference. So that if this one is passing through the center, it is diameter, then it's going to subtend an angle of 90 degrees. So that in the end, then what we have is that VSR. So angle P2 is equal to angle, this angle here, the whole angle, we can call it RSV. It's equal to the angle RSV, right? It is equal to the angle RSV, which is equal to 90 degrees. Right, so why is this the case? So we can put some justifications. What are the justifications? Let's write them down. Let's write them down. So that in the end then, okay, so the RSV, the reason is RSV equals 90 degrees. Why is that angle in semicircle? Angle in semicircle. But also angle P2, angle P2 is equal to 90 degrees. Why is P2 equal to 90 degrees? This is the reason here. Because of the line, right, because of the line from center to midpoint of chord. Line from center, line from center to midpoint of chord. Line from center to midpoint of chord. So therefore, triangle ROP is similar to triangle RVS. Why? Why are these? Because here it's about angles, it's about angles that are equal, it's about angles that are equal. So angle, angle, angle. Right, angle, angle, angle. So we've been able to establish the fact that the triangle ROP is similar to triangle RVS. And we established that. So that was 10.2.2. Look at this way we have proven this and think very carefully about how we have proven this. You need to watch this video again and then do the homework that I'm going to send you. Okay? And make sure that you watch the videos first before you try because now some of the questions are a little bit complex. Okay, yeah, these things are being recorded. Even if you lose some of the little, yeah, if you get cut because of the network and you reconnect, the recording is not going to be cut. So that is the story. So you need to just note that. Okay, now we need to work in this one. And now we need to do 10.2.3. So now here we work in triangle. RVS and triangle. RST. Okay, let's see. RVS, prove that triangle RVS is similar to triangle RST. RST. RVS. Both of them have the angle R. So now you need to just say angle R equals angle R. Okay, because if they say RSV, the triangle that both of them have the angle R. So if you look at the RVS, which is RVS, and also RST, RST, both of them have the angle R, so which means the full angle R is equals to angle R, which is a common angle. Common angle. Right. So in the end, then, if you look at the triangle RVS, RVS, it has an angle of 90 degrees here because this is a diameter, and a diameter subtends an angle of 90 degrees at circumference. But moreover, we also look at the triangle RST, right? So the triangle, right? RST, RST. So this one is a diameter, okay? Because we're told that RS is a diameter. So if RS is a diameter, RS will subtend an angle of 90 degrees at circumference. That's a grade 11 theorem. So you need to always note that. Right, that's a grade 11 theorem. So if you have an angle, a line through the center, it subtends an angle of what? Of 90 degrees at circumference. And therefore, we have that this angle is 90 degrees. So this is something that you need to state in the triangle RST, but also now we have the triangle RVS, so that you have that at this point, angle RTS, angle RTS is equal to the angle RSV, yeah, which is RSV, and this is 90 degrees. Why? It is an angle in semicircle. Angle in semicircle. So that RTS is equal to angle RSV, which is equal to 90 degrees angle in semicircle. Okay, right. So now, which means therefore, next thing that you need to do is to say that, okay, now you already have like two angles that are equal to each other. And then now you need to establish a third angle that is remaining in the triangles. So in the triangle RST, you already have the angle R that was mentioned, but you also have the angle T that was mentioned. So you're only left with this angle here, and we need to establish that little bit of the angle there. Okay, we need to establish that little bit of the angle there, right? The angle V, this one, right? The angle V is equal to the angle TSR. The angle V is equal to the remaining angle TSR. Right. Why? And this is angle V is equal to the angle TSR. TSR. Why? Well, it's the sum of angles of triangle. Okay, so here you have the sum of angles of triangle. Sum of angles of triangle. So that in the end then, okay, what you have you are able to establish. Therefore, you have these three angles that are equal to each other. So that in the end, then we have, therefore, that the triangle RVS is therefore similar to triangle RST. Why? Angle, angle, angle. Right. You already have that. You have the three statements there that you need for the similarity of the two triangles to show, therefore, that triangle RVS is therefore similar to triangle, that one, RST. Right. So it's angle, angle, angle. So we have been able to do 10.2.3, then we need to do 10.2.4. To do 10.2.4, we proceed as follows. Right, so 10.2.4 is way too easy. We need to prove that st squared is equal to vt times tr. Okay, so how to prove this? To prove this, you need to decide the triangles in which to work. Right, so this can be seen as st equals vt-tr. So that st over vt is equal to tr over st. Okay, yeah, we cross multiply these so that st, and then is vt-tr. But also you can do it like this. You can write this one as st over, you can divide by tr. You can divide by tr. Okay, just showing here. Here you can decide to divide by tr. Okay, so if you divide by tr, okay, here in this equation, you can divide by tr so that you have vt. Vt is left over st. Okay, so you can write like this. Why do we write like this? We write like this because of a variety of reasons, but we need to establish some results. Yeah, okay. We need to just decide which the triangles in which to work. So in any case, what this is showing us, we're gonna work in triangle RTS and triangle STV. Okay, let's look at this. If you look at this one here, and now it has some VT. Right, so if it has some VT and also it has some ST, VT, ST, and then TR. So if you look at this one, this says that ST over VT. So you have ST over VT. And this is TR, TR over ST. And obviously it actually centers around the triangle STR. Rather, yeah, the triangle STR, or the triangle in called RTS, but also this triangle here, STV. Good. My goodness. We continue. In these two triangles then that we've just got, it means therefore that the angle, we know that the angle RTS is equal to VTS. The angle RTS, okay, this angle is 90 degrees because it's an angle obtained by diameter. But also, in this angle here in the triangle STV, also this angle is 90 degrees here. So that RTS is VTS, which is 90 degrees. Why? Okay, because this is a straight line, this is a straight line, so 90 plus 90 must be 180 degrees. Adjacent angles on a straight line add up to 180 degrees, so that if one is 90, the other one is 90. Why must they both be? If one is 90, the other one must be 90, because they must add up to 180 degrees. So you see, the reason here we state is that these are actually angles on straight line. Angles on straight line. Okay, these are angles on straight line. Can even say these are essentially adjacent angles on straight line. So that in the end, we have this. Angle R. Oh, yeah, we'll continue. So that angle R equals, okay, yeah, the angle R here. So that the angle R is equal to what? Okay, because this one is 90 degrees. So the angle R is 90 degrees minus TSR. The angle R is 90 degrees minus TSR. The angle R is 90 degrees minus TSR, which means that the angle R is equal to, okay, it's equal to the angle TSV. Look at this. Very tricky to observe, but pay particular attention because now we're dealing with this here, but we're also establishing a very important result. Okay. We have seen that RTS is 90 degrees, but also this one, VTS is 90 degrees, so that these are adjacent angles on a straight line. The angle R is equal to the angle TSV. The angle R here is equal to the angle TSV. Right, and the reason for that is that this angle here also is 90 degrees this, because this is the diameter this, and a diameter subtends an angle of 90 degrees at the circumference of a circle. So that now we can then say 90 degrees minus TSR. So 90 degrees is this one. 90 degrees, this is 90 degrees because it's obtained by diameter. So now if you then say 90 degrees minus TSR, you get this angle here. You get the angle TSV. So that the angle TSV is 90 degrees minus TSR, but the angle R is also 90 degrees minus TSR because the angle R here is, this is 90 degrees, but this plus this is 90 degrees. So that now you can then say the angle R is 90 degrees, the angle R is 90 degrees minus, which is this 90 degrees, 90 degrees minus TSR. Okay. Try to follow, okay? Try to follow, try to pay attention there. And then now we have two angles that we've established. We just need one more because we need angle for the similarity here and to establish this proportionality result. So the angle TSR, the angle TSR, TSR is equal to what? Okay, we established that one. The angle TSR right, so okay. The angle TSR is equal to what? Right, so this angle TSR, which is this one here, is equal to the angle V. Right, it's equal to the angle V. Well, obviously, I mean, this is true because if in these triangles we're working on the triangle RTS and the triangle STV, RTS, STV, you already exhausted two angles in the triangles, so that this angle V was the one remaining, because we've already exhausted some of the angles, like your VTS, This one we have taken care of, 90 degrees, this one, but also this one, 90 degrees. We went on to mention angle R, right? And then we mentioned angle R with the angle TSV, this one here. So which means that the angle TSR is equal to the angle V. Okay? And therefore, triangle RTS is, so this one is what? You can say third angle or sum of angles of triangle. Sum of angles of triangle. Sum of angles of triangle. So that triangle RTS is very similar to triangle STV. And the reason for this is angle, angle, angle. Right, so that in the end, then we have that these triangles here are similar to each other. They're similar triangles. Okay, because they are similar triangles, what do? We actually are able to then say that we can take them. We can take this. So we can then say RT over. So you take RT, the first two, and then you take RT over ST is equal to. Then you deal with the last two. The last two, you can call it TS, but let's just call it ST to make ST the same as ST. And then now the last two, and then here you also have, you can call it TV, but let's call it VT. And then now we cross multiply these things here. If you cross multiply this, what you get? So you have ST times ST, which is ST squared is equal to VT times TR, or we can call it RT, TR. Yeah, let's call it RT. Let's call it TR. Right, we're calling it TR like this. Right, so you multiply ST times ST is ST squared, which is equal to VT times RT. VT times RT. Okay, we've been able to prove this one. Please just try to pay particular attention and make sure that you follow. And this presents sort of the highest level of geometry that you will ever get in school. You need to watch these videos and then try the exercises that I sent you and the exercises that I'm going to send to you. And we shall go deeper even tomorrow, Sunday. We shall do the same thing. We shall do like different questions, but we're going deeper at 4 p.m. and also at 8 p.m. we're meeting, and to make sure that we become the best we can be. I want us to spend some time doing also other forms of geometry. We're gonna do an what you call coordinate geometry. Your teachers might be done with this geometry in school, so they might be doing what you call the coordinate geometry. Let's just spend some time to do coordinate geometry here together, okay? Because it's very, very important for you that you do not know only Euclidean geometry, but you also know this one here, because it's going to make you a doctor, it's going to make you an engineer, it's going to make you the best you can be. So yeah, pay particular attention to this. In the diagram below, point P has the coordinates 1 and 0, 1 and 1, and then you have also Q has the coordinates 0 and -2, and R are vertices of a triangle, right? And PRQ equals theta, right? We have PRQ equals theta. The x-intercepts of PQ and PR are M and N respectively. The equations of the sides PR and QR, PR and QR are these respectively. T is a point on the x-axis. So T is a point on the x-axis as shown. Determine the gradient of the line of the gradient of QP. Right, how to find the gradient? So we're going to discuss the concept of what you call the gradient. Okay, I know that the gradient was done at grade 10, but at grade 11, also at metric, it really resurfaces the notion of a gradient. Right, so the gradient of QP, which means that the gradient of QP, it is change in Y, change in X, which is the, right, which means therefore you have y2 minus y1 over x2 minus x1. And then this is x1, y1, this is x2, y2. Right, so that in the end, then, what you have is that what is y2? Y2 is minus 2, y1 is 1, x2 is 0, x1 is 1. And therefore, you have minus 3 over minus 1, and this is 3. So we're interested in finding the gradient of PQ, of QP, so that you come here and you then say the gradient of QP is equal to 3. Okay, and this is how we find the gradient. So I'm going to send you more exercises on the group so that you can try these. But first, I must send you the exercises, and then you try the exercises with the answers, without the answers, and then I can send you the answers then at a later stage for you to see the things. But I need to mark your work. I'll be reinforcing more rules on the group to make sure that people submit their work and I mark it there. Right. The next question is you need to prove that PQR is 90 degrees, angle PQR. So angle PQR is 90 degrees. You need to prove that this angle is 90 degrees there. So now to prove that this angle is 90 degrees, the couple of things that you need to know. You already know that the gradient of QP, what is the gradient of QP? Right, we have seen therefore that the gradient of uh, uh, QP is 3, and this, why is it 3? It has been proved in 3.1 above. Okay, so in 3.1 above, we've been able to establish that QP is 3. But also, now we have that the next thing that you need to establish also is the gradient of QP, and also the gradient of the line that meets PQR, that makes PQR. This line here has the equation. So the equation x plus 3y plus 6 equals 0. You need to make y the subject of this equation. It must be written in the form y equals mx plus c. Okay, let us solve for y here, which means 3y is minus x minus 6. 3y is minus x minus 6, so that y is minus 1 over 3x minus 2. Right, so this is what we have. And therefore, what is the conclusion of this? Right, so that in the end, then we have that the gradient of QP times the gradient of QR, the gradient of QP times the gradient of QR is 3 times the QR is minus 1/3, and minus 1/3 is minus 1. Right, so now because the product of the gradients is now minus 1, the conclusion therefore is that PQ is perpendicular to QR. And therefore, PQR is equal to 90 degrees. And therefore, PQR is equal to 90 degrees. Okay, we continue. So that PQR is that, how do we know that is 90 degrees? Because the product of the gradients, because the gradient of QP times the gradient of QR is minus 1. Okay, now I'm going to mention something also that you need to know. If the gradient of line 1, if the gradient of line 1 times the gradient of line 2, okay, equals minus 1, it means in theory that line 1 is perpendicular to line 2. If the gradient of line 1 is equal to gradient of line 2, well, it means that line 1 is parallel to line 2. Okay, if two lines have equal gradients, it means they're parallel to each other. If the product of the gradient of line 1 times the gradient of line 2 is -1, it means the two lines are perpendicular to each other. Because here now we have to prove that the angle PQR is 90 degrees. How do you prove? You just need to prove that the gradient of these times the gradient of that is -1. Okay, the gradient of QP is 3 already, we got it. But the gradient of QR is -1/3. Is -1/3, and therefore, if you multiply 3 and -1/3, you get -1, and that's the answer. Next point. Determine the coordinates of R. Determine the coordinates of R. Now, to determine the coordinates of R, the couple of things that are very important for us to consider. Where is R? It's this one. What are the coordinates of R? And how would you find the coordinates of R? Right, to find the coordinates of R, the couple of things that we need. What do we know about R? R is nothing other than a point of intersection. So in 3.3, we need to find the coordinates. So we know that these are like simultaneous equations. This is the equation of this line and this, and they're intersecting here. There's a point of intersection. You need to find the coordinates of R, so you need to solve this simultaneously. So one of the equations is -x plus 2, and the other equation is this one, which is x plus 3y plus 6 equal to 0. Let's make y the subject, which is -1/3. Okay, let me just show some steps here to make sure everybody's following. Let me not just run overhead. Right, so we have 3y, the subject of the equation, and is -x minus 6. You divide by 3, which is -1/3 x minus 2. And then now at this point, these are the equations, and they are now you can just make them equal to each other. So now we're gonna find the point of intersection. How do you find the point of intersection? To find the point of intersection of two lines, you equate them. So which means that y is equal to y. You make y is equal to y. What is y here? Y is -x plus 2. What is y here? -1/3 minus 2. We solve for x. Right. So if we solve for x, what do we do here? Right. We bring this one, which is -x plus 1/3 x, which is -4. You multiply through by 3, which is -3x plus x, which is -12. -3x plus x, which is -12. -2x, which is -12, which means you divide -12, you divide by -2, and you get a 6. And once you get that x is 6, you substitute into one of the equations to get y. So obviously at this point, what do you have? Y is -x plus 2. And y is -6 plus 2. What is -6 plus 2? It is -4. The coordinates of R, x is 6 and y is -4. X is 6 and y is what? Y is -4. X is 6 and y is -4. So we have found the coordinates of what? We have found the coordinates of R. We have found the coordinates of R. Right. Thank you so much. It was interesting seeing you guys today. I'm going to see you guys again tomorrow at 4 p.m. And also at 8 p.m. Right. We must thank you for joining us today. It was exciting being with you. And obviously, tomorrow is not at all different. It's a good Sunday, and we're going to have more mathematics and more science time. It is my hope that I'm doing more mathematics today because some of the guys missed earlier on. And that's the reason why I am doing more mathematics. But also, it's a repeat. Some of the questions are repeated.